Today we are going to study about steroid. Steroid is an organic compound which have four rings arranged in a specific molecular configuration. If you could see, here we have a 17 carbon atom, four rings, and these three ABC rings are arranged as that of the anthracene, and then a 5-membered ring is attached with it. So the core structure of the steroid has 17 carbon atom, cyclopentane no perhydrophenanthrene ring. So this is the name of this parent structure of the steroid. There are three 6-membered cyclohexane rings A, B, C, and one 5-membered cyclopentane ring D. Steroid may have different functional group attached to these four rings, or they could have some oxidation state present in the ring. So based on that, we give them different classification and different names. If we go to the nomenclature, almost all steroids are named as derivatives of any one of the following basic steroid rings. There are basically 5 basic steroidal rings. Let me draw it for you. First one you can see 5 alpha beta gonane. So if the parent structure have this, if the structure has this parent ring, the 4 rings fused together, total carbon atom 17, then it is called 5 alpha or beta. It will have an gonane. If this ring have one more methyl group attached here, it will become 5 alpha beta estrane. Now the carbon atoms are 18. If it has one more methyl group, carbon atom will be 19, and it will become 5 alpha or beta androstenedione. And if it has ethyl group attached here, then it will become 5 alpha beta pregnane, and carbon atoms in this case are 21. These are the 4 forms. If we talk about the fifth one is slightly complicated than all these 4. It is basically cholestane. The cholesterol is one of its type. So this is the parent structure. It will have a methyl group attached here, one hydrogen here, one hydrogen here, and 1, 2, 3, 4, 5, 6, and a methyl group here. So this kind of structure. This is also methyl group. So if this kind of structure is present, then it is 5 alpha or beta cholestane. Okay, these are the 5 different forms, 5 different names we give to the all the derivatives of steroid. So these were the structure. If you have 4 rings fused together and no substituents guanine, if it has a substituent here, it is estrane. If it has 2 methyl groups as substituents here and here, then enderastane. If one ethyl group is also attached on the 5-membered ring, it becomes pregnane. And lastly, our cholesterol. This is cholesterol. Okay, and if you see the structure of cholesterol, we have wedged and dashed bond. So this is very basic thing, everybody know this. Solid line indicates the group which are above the plane of the compound. Like जो हमारा ये rings हैं, इसके plane से ऊपर में हमारे hydrogens pointed out होंगे above the plane of the paper, and dash line are below the plane. So basically जो above the plane है, those are named as beta configurations, and below the plane are named as alpha configuration. And the alpha beta is indicated by the substitution on the 5th position. When we had our parent compound, we had the numbering. Numbering was like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This was the numbering. So on the 5th carbon, whatever the substitution is will define whether your structure is alpha or beta. So the configuration of hydrogen at the C5 position is always indicates the name. So if you see the structure of cholesterol, this is our alpha hydrogen. So the name will be 5-alpha cholesterol. So the compounds which have 5-alpha will belong to the series allo series, and 5-beta will belong to the normal series. Okay. If the double bond is not between the sequentially numbered carbon, in that case both carbons are indicated in the name. That means अगर हमारा bond let's say 8 and 14 के बीच में है, so these two are not in the sequence, or you can say 9 or 11 के बीच में है, again these two are not in sequence, so we will have to give the numbering. Similarly, if the bond is double bond is between 5 to 11, so you have to give the numbering, otherwise this symbol delta is used to indicate carbon-carbon double bond in steroid. Okay, so when we gave the numbering, it was like this: 1, 2, 3, 4, 5. So on the 5th carbon we have a double bond, so we will write it as delta 5 androstenane. So this was the parent compound androstenane, and since it has a double bond, it is indicated by delta, and 5 is the 5th carbon number. So that way the naming is done. When a methyl group is missing from the side chain, this is indicated by a prefix nor with the number of carbon atom which are disappeared. So that is basically, let's say we do not have this methyl group, so we will have to write the nor androstenane in the beginning of this name, and you will have to mention the carbon number. So this carbon is 13 carbon. So we will be naming it, this is the 13th carbon. So if we are removing this methyl group on the 13th carbon, we'll name it as 13 norandrosterone in that case. So that way the naming are done. This alpha and beta steroid, this we have already discussed. The below the plane are given beta, alpha name, and above the plane are given beta. So that this has been already discussed. Now classification of sterols. Sterol is basically classified into 5 different class. First is sterol, second is sex hormone, third is cardiac glycoside, fourth is bile acid, and fifth is saponogenin. All these classes are basically based on the structure these steroid have, the parent structure. In case of sterols, sterols have a aliphatic side chain and they usually contain one or more hydroxy group. If you see the example, cholesterol. Cholesterol is a sterol. It has a aliphatic side chain and a hydroxy group. Similarly, if we go to the sex hormones, the R bears a ketonic or a hydroxy group. That means side chain में या तो ketonic group होगा, otherwise it will have a hydroxy group, and mostly possesses 2 carbon side chains. So if you see our progesterone or testosterone have a aldehyde group and 2 side chains. Similarly, testosterone have 2 side chain and a hydroxy group. So that ways, these are the 2 classification. Third, cardiac glycoside. Cardiac glycoside is where R is a lactone ring. So this is lactone. So R is a lactone ring. Glycosides also contain sugar linked through oxygen in other parts of the molecule. इसमें कहीं ना कहीं sugar linked होगी. Normally on hydrolysis, it yields this sugar together with cardiac glycone. Okay. So if you see the example, desoxygenin is one, desoxygenin is second one. It has one more hydroxy group than the desoxygenin. Similarly, getoxygenin. So all of them have lactone ring present. Okay. There is a difference in the places where hydroxy groups are attached. In this case, you had only 2 hydroxy groups. In desoxygenin, you had 3. In G-toxygenin, again you had 3 hydroxy group, but this time the position of hydroxy group has been changed. Okay. Next we move to bile acids. R is essentially a 5 carbon side chain ending with a carboxylic acid moiety. So basically जो हमारा R है, जो हमारा यहाँ पे साइड चेन था सब हमारे स्टीरॉइड में, वो इस केस में it's a 5-membered carbon side chain, and generally it ends up with a moiety, carboxylic acid moiety. It could be a carboxylic this means this RH is a hydroxy group, then only it will be a carboxylic acid. Okay, now name depends upon what are the substituents. Here we have R1, R2, R3, R4, 4 different substituents. So in case of bile acids, RH will always be hydroxy group, then only it is a carboxylic moiety. So this is fixed, R4 will be OH. But if you see the other 3, R1, R2, R3, if all 3 are OH, then it is called as cholic acid. If the first 2 are hydroxy and that 2 on alpha, alpha means below the plane, and hydrogen, R3 is our hydrogen, then it is called as cyanodeoxycholic acid. Again, if you see R2 is a hydrogen and these 2 are hydroxy group, then it is called as deoxycholic acid. Now if R1 is hydroxy, R2 is also hydroxy, but R1 hydroxy group is below the plane and R2 is above the plane, then it is called as ursodeoxycholic acid. Third category where R2 and R3, these two are hydrogens, while R1 is a hydroxy group. It is called as lithocholic acid. So basically for bile acids we have a 5-membered carbon side chain with a carboxylic acid moiety. So that is the characteristic of the bile acids. Now we come to the last category, that is sapogenins. In this case, the R contains an oxacyclic ethereal ring system. So this much is the parent structure, parent rings. All 4 are part of the parent ring, but again we have 2 more ring systems, and both of them are cyclic with a oxygen. That means both the rings are heterocyclic rings, and specifically oxygen. So that's why it is called ethereal. Functional group ये ether होता है. So basically that's why it is called ethereal. Oxacyclic rings है. So if the substitution over this is oxacyclic ring system, then it comes into the category of sapogenins. Example, digoxgenin. Digoxgenin is the example. This sterols can again be further subdivided into the 3 categories. The first type, that was sterol, which had a R, that means alkyl. This we had a aliphatic side chain. हमारी एक aliphatic side chain थी and had hydroxy group attached, 1 or more hydroxy. So this sterol can be further divided into 3 different categories. Those are juicesterol, phytosterol, and mycosterol. So as the names suggest, these are the sterols. These are the okay, this is wrongly written. Zoosterol are such sterol, those are obtained from animal kingdom only. That means सिर्फ animals में present होते हैं, those come into this category. Example, जो cholesterol होता है, cholesterol is present in animals. Phytosterol, so phyto means plants. Such sterol, those are derived from plant sources, are called phytosterols. Example, ergosterols. Third is mycosterol. So such sterols are obtained from either yeast or fungi.